All right, we're going to go through worksheet 51 really quick. Excuse me. The first four, we got our graphs, right? Again, like I said, this is where I feel like we're feeling really confident. So for this first one, I'm going to start at -3. My slope is -1 over 2. So I'm going to rise down and run right. 1 down, 2 right. Follow that pattern, go back to the beginning. Up 1, 2 left, just like that. And for the next one, I'm going to start at -1, which is right there. My slope is -3 over 2. I'm again going to go down and to the right. Boom. I'm going to reverse it, go up and to the left, up and to the left. All right. So if I were to get a ruler and draw my two lines, we can see they intersect right down there at that point that I circled. So for us to find the solution, we just need to identify what those coordinates are, which in this case is 2, 4. Just like that. For this next one, number 2, I'm going to start at -1 for the first term. My slope is 1 over 1. I'm going to go up and right all the way up, down and left all the way back. My next term starts at my next equation starts at +2. My slope is 4 over 1. So I'm going to go up 1, 2, 3, 4 over 1. I'm going to go down 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So again, as long as we don't have the same slope for both lines, we should see an intersecting point. That's our solution, which in this case is at my x value is -1, my y value is -2. All right, so hopefully those first two ones look good. Very quickly through the next two. I start at -2. I'm going down 1, right 1 this time because my slope is -1 over 1 for the blue line. All the way up. My next one starts at 4, and I'm going down 7 over 1. Down 7, boom, over 1. And I only have room for those 2 points, but that's fine because I hit my intersecting point right down there. And this solution is at +1, -3. Last but not least, this is our special case that we talked about. I'm going to start at 4. Now I'm supposed to go up 5, right 4, but I can't go up 5. So instead I'm going to reverse it. I'm going to go down 5 and left 4. Down 5, left 4. Down 5. Well, I can't go left 4 anymore, so I'll leave it as that. And for this next one, I'm going to start at 2. And again, I'm going up 5, right 4. I don't have space, so I'll go down and left. Down 5, left 4. Just like that. Now these two lines are super close together, but they will never ever intersect each other, so my solution is no solution. Okay, take a look at those 4 graphs, see if those look exactly like mine. Hopefully they do. Moving on to the bulk of our study guide, choosing whether we need to do substitution or elimination. Now, like I said before, we know we're doing substitution when we see y equals. So that's going to be these two down here. I'm going to do substitution. 5 and 6, I don't have y equals, so I'm going to do elimination, right? So with elimination, I'm just combining these two equations together. 6x minus 4x is 2x. 4y minus 4y cancels out. And -10 plus 16 gives me 6. Now all I need to do to get x all by itself is divide both sides by 2. And 6 divided by 2 gives me 3. So I know right away the first number in my solution is going to be 3. But now I got to figure out the y. I'm going to take this first equation, and I'm going to replace the letter x with the 3 I just found. 6 times 3 plus 4y equals negative 10. Now the only letter I have in my equation is y, so I'm going to work out everything around that y in order to get it all by itself. First things first, we'll multiply 6 and 3 to get 18. Then we'll subtract that 18 to get 4y equals negative 28. And of course, our last step is always going to be to divide by 4, giving me negative 7 as my second piece of the solution. So we take the x from the first part, we get 3. Plug that in to get y for our second part, negative 7. Boom, my solution is 3, negative 7. Now same idea over here. I don't see y equals in the beginning, so I know I'm going to add these together. This x, we got to remember, hopefully we always remember, has a 1 in front. So 3x plus 1x is 4x. 6y minus 6y goes away. And negative 3 plus 7 is the same as 7 minus 3, which is 4. Then I'll just divide both sides by 4 and get x equals 1. Again, there's half my answer already. Now I'm going to plug 1 back in. I'm going to use this second equation just because x is already by itself, which is going to make things a little bit easier. 1 minus 6y equals 7. Because this 1 is positive and I need to do the opposite, I'm going to subtract it to get negative 6y equals 6. And then I'll divide by negative 6 to get y equals negative 1. All right, this is why we spent so much time working on solving equations, because it's going to show up in all these different lessons as we move on and as you move on into high school now too. All right. So that's elimination. We'll look at some more elimination on the backside. But switching gears here to number 7 and 8, I see y equals y equals, y equals y equals, and I'm going to do substitution, okay? So what that looks like is I'm going to take this first expression, 7x minus 23, and I'm going to set it equal to this second expression, negative 4x plus 21. Right, I can't solve for anything when I have two different variables in the equation, but now I only have an x, so I can get that all by itself. I just got to move my number to the right, my letter to the left. I can do that by doing the inverse of them both, which gives me 11x minus 23 equals 21. Inverse of minus 23 is plus 23, and I get 44. Once I divide both sides by 11, I get a nice neat answer of x equals 4. And there's the first half of my solution once again, but we're not done. I'm going to take this 4, I'm going to plug it in again where the x is at. So I take my first equation, you could take the second, it doesn't matter. And my x goes away, the 4 goes in its place. Right? All I did was substitute this 4 in for this x. Y equals 7x minus 23. 7 times 4 is 28. 28 minus 23 is 5. So there's my second half of the answer. Y is equal to 5. Same thing with number 8. I'm going to take negative 4x minus 12, set it equal to 4x plus 20, and I'm going to solve. I'm going to bring this x over to the left, giving me negative 8x. I'm going to bring this negative 12 over to the right by adding it, giving me 32. And I'm going to divide by negative 8, leaving me with x equals negative 4. Halfway done. I'm going to take, this time I'll take my second equation, why not? Plug that x value in and solve. So this x came out, this negative 4 goes in. 4 times negative 4 is negative 16, and negative 16 plus 20 is just positive 4. So take a look at those first 4, see how those look. If there's any changes you need to make, you can feel free to pause it and make those changes real quick. Now, some of you may have looked at this problem and went, hey, negative 4x and 4x cancel out. maybe I can use the elimination method. You totally can, but here's how that would look. If I wanted to do elimination here, right, these 4x's cancel out. Negative 12 plus 20 is just 8. But we also have to add these two y's together. Remember, this is a 1y and a 1y, which makes 2y. And we get y is equal to 4. That is what we found by doing substitution. Now what I would do is I would take y equals 4 into the second equation, and I would replace y with 4. Right, now my equation is a little bit turned around from what we normally see, so I wouldn't recommend doing this. If it starts with y equals, I would suggest you just do substitution. But you could always subtract 20 from both sides, getting negative 16, and dividing by 4 to get x equals negative 4. So by doing this elimination method here, we should get negative 4, 4, exactly what we got by doing substitution. So if you noticed that and got a little confused, that's great. I'm glad. That means that you're recognizing these patterns. You could do it either way. When we have a slope-intercept form equation, it's a little bit trickier to do elimination just because of the way everything ends up working out. But if your algebra is solid and you're confident in what you're doing, you should be fine either way. All right, 4 up on the top. I see y equals. I know I'm going to do substitution. So I'll take negative 4x minus 5 and set that equal to 5x plus 13. I'll bring the 5x over to the left, giving me negative 9x. I'll bring this minus 5 over to the right, giving me 18. And I'll divide by negative 9 to give me negative 2. I'm going to take my second equation just because it's got all positives, and I like working with positives better than negatives. I make less mistakes when I do that. I don't know about you. 5 times negative 2 is negative 10. Negative 10 plus 13 is positive 3. There's my solution, right? It goes quick once we know what we're doing and once we're feeling confident. I don't see y equals on number 10, so I'm going to eliminate. Looks like my x's are going to cancel out here because those add together and make 0. 9y minus y is just 8y because of that 1 in front. And negative 15 plus 23 is just like doing 23 minus 15, which gives me 8. Divide both sides by 8 to get y is equal to 1. So this time I solved for my y value first. Now I'm going to take that y, plug it back into one of my equations, this time for y again, and I'm going to solve. So this negative y is like a negative 1, so I got to do the opposite, which is plus 1. And that's going to give me a nice clean answer of x equals 4. Okay, if you end up getting some kind of weird fraction, you know you did something wrong right away. Okay. Number 11, I know I'm going to eliminate here again because my x's will cancel just like that. X minus x is 0, don't need that. 8y minus 3y is 5y. And negative 22 plus 12 is negative 10. Divide both sides by 5. And I get my first piece of my answer, y equals negative 2. I'll take my first equation and plug in negative 2 for y, making sure I'm plugging it in for the right letter. I get x minus 16, which means I got to add that 16 over, and I get, what is that, negative 6, comma, negative 2. All right. Finally, number 12, y equals y equals. I'm going to do substitution. I'll take this first guy here, set it equal to my second little expression. Minus 4x over to the left gives me negative 9x. minus 7 over to the right gives me, oh, what's 7 minus 7? 0. If I take anything and divide it by, if I take 0 and divide it by anything, I get 0. Well, that's going to make plugging in a lot easier, because again, anything times 0 also gives me 0. And 0 plus 7 is just 7. Right? So once we get comfortable with this, hopefully we are comfortable with it already, but, you know, some of us it takes a little longer than others, which is fine. But the more comfortable we get, the quicker it goes, the easier it is. 13 and 14, we're switching gears a little bit. We're checking out which system has this solution. Now, there's a couple ways we could do this, right? The way we learned was to just guess and check. Well, not guess and check. We have the numbers. But plug and check. You could also, if you wanted to, just solve this. But take a look. These x's aren't going to cancel out. These y's aren't going to cancel out. So trying to do the elimination method here would not really work, okay? Same thing with part B. The x's don't cancel, the y's don't cancel. What do? Well, I take my x value of 1 and my y value of 2, and I plug those in. X is 1, y is 2. And I'm going to see if this works out. 2 times 1 is 2. 3 times 2 is 6. Does 2 plus 6 equal 8? It sure does. But I don't want to test it once. I want to test it twice. I want to make sure it works with both. So I'll take my second equation. X is equal to 1. Y is equal to 2. Negative 4 times 1 is negative 4. And negative 4 minus 2 is negative 6. Right? So I know that this first answer, A, is a system that does have the solution 1, 2. Right? The key here is it has to work for both, so we have to test them both, unless the first one's wrong. If I took this second problem, B, x minus y, well, that's 1 minus 2. That does equal negative 1. Hey, it looks like this one's going to be right as well. But let's plug in x for this second one, too. 5 times x. Hey, Miss Brown. Oh. Sorry about that. So I plug in 1 for x. I plug in 2 for y. 5 times 1 is 5. 4 times 2 is 8. 5 minus 8 is negative 3. Ooh. Negative 3 does not equal positive 3. That one does not have a solution of 1, 2. All right. So same idea with 14. We're just plugging in. X is 0. Y is negative 4. X is 0. Y is negative 4. 3 times 0 is 0. Negative 2 times negative 4 is 8. And 8 is equal to 8. So far, so good. But let's check. Y is a negative 4. X is 0. Oh, and again, we get negative 4 equals positive 4. That is not true. So A is not going to work out for that solution. Let's try part B. 8 times 0 plus 3 times negative 4. 0 minus 12 equals negative 12. Well, that is correct. For the second one, 0 minus 5 times negative 4 equals 20. Well, negative times a negative is a positive, and 20 does equal 20. So that one works out for 0, negative 4. You got to test them all. On the test, maybe they're both right. Maybe they're both wrong. Just because we circled A doesn't mean we necessarily are going to cross out B, okay? You have to work it out, test it out, see how it goes. And finally, the easiest part, saving the best for last, number 15. What is the solution to the system? Well, the solution is where the two lines intersect, which is right there. So if I want a solution in the form x comma y, I'll take this point, I'll look down at the x-axis. It's labeled in case you forget. And my x-coordinate is negative 3. Here's my y-axis. I look over there, and I see positive 3. Same thing here. My intersecting point has an x-coordinate of 3 and a y-coordinate of negative 1. 3 comma negative 1 is my solution. It's a bad square, but it's okay. All right? So hopefully that helps out. Hopefully you got them all right. If not, hopefully you got most of them right. The test is going to be like half as many problems, but I wanted us to get a lot of good practice on this going into it, okay? If you have any questions or anything like that, you need some clarification, just let me know. I'd be happy to help.